All right, so this is our notes on acid versus bases. So either get your Cornell template open on Google Classroom or get out your notebook. All right, here we go. So our central question for this one is, what is an acid and base? So we'll learn what the characteristics of both. So an acid, some of the things you may be familiar with is lemons, but it releases hydrogen ions into water. So when it goes into water, an acid releases more hydrogen ions, okay? And so the pH is below 7. And we'll talk more about pH. It tastes sour. It's corrosive to metals and corrosive to stones, buildings, and statues. Examples of some acids you may have seen, pH of 1, which is very high, is hydrochloric acid or battery acid, which you know if you get on your skin, burns right through. A pH of 2 is stomach acid. A pH of 3 is lemon juice. pH of 4, example, is tomatoes or acid rain. pH of 5 is regular rain. And then a pH of 6 is milk. So milk is actually considered an acid as well as regular rain. Bases, on the other hand, instead of releasing hydrogen atoms, right, because water is made of H2O, it releases hydroxide, so an OH ion into the water. And its pH is above 7. And they usually taste bitter, they're slippery feeling, and can still be corrosive to skin. So both bases and acids have this characteristic. Some examples of bases, pH of 8 is ocean water. pH of 10 is antacids like Tums. pH of 11 is cleaners. pH of 12 is baking soda. pH of 13 is bleach. And pH of 14 is drain cleaner or sodium hydroxide. So the way we measure if it's an acid or base is through the pH scale. Okay, and the pH scale actually refers to, let that bell ring, pH means potential of hydrogen, and it measures the acidity of liquids. Each numeric change in pH means that it represents a factor of 10. So if we go down, that means we're increasing, as we're going down, we're making an acid, and we're increasing the hydrogen ions by a factor of 10 each time we go down one. Here in the bases, if we go up, we're actually increasing the hydroxide ion by 10 fold or 10 times. And you can also think we're decreasing the hydrogen ions by 10, okay? The POH scale is called the potential of hydroxide, and it measures the basicity of liquids. So each numeric change in the POH represents a factor of 10. And so factor of 10 basically means that it's decreased. If it goes down, is decreasing the hydroxide ions by a factor of 10. And if it's increasing, going more towards the base side, then we talk about that is increasing the hydroxide ions. Now, you will never hear anyone say POH. Okay, you will always say pH, and it's the potential of having hydrogen or hydroxide. So the main thing to understand is as you go up in the pH scale, you're increasing hydroxide ions, and as you go down, you're actually increasing hydrogen ions. Okay, and so here's kind of a picture of what it would look like. So more high hydrogen ions, the lower the pH, so very acidic. So this side would be definitely a low pH because it has lots of hydrogen. If it has lots of hydroxide ions, negative anions, then we have a high pH because now it's very basic. So here's kind of a big scale of all kinds of different things. And so 7 is what we consider absolutely neutral. And so neutral is pure water. So in pure water, we don't have any separation of the hydrogen and hydroxide ions. And what kind of water am I talking about? I'm not talking about the water that comes out of your tap. I'm talking about water you can buy. It's called distilled water, which means all other ions are removed. Still in your drinking water, you have things like low amounts of salt. You might have chlorine if they've used that to clean the water. So you have different things in your tap water. If you actually drink distilled water, you would actually get dehydrated because your body actually requires all those small little ions as well in your water. And so from 0 to 4, we call that a strong acid. If it's from 4 to 7, that's a weak acid. 7 is neutral. 7 to 10, we call a weak base, and 10 to 14 is a strong base. And here's some examples here on this chart. So what does neutral mean? Neutral pretty much means that as a pH of 7, it's absolutely balanced with hydrogen and hydroxide ions, even amount. And it creates pure water, distilled, or we can also call it deionized, which means it has no other ions in it. Tap water, like I just mentioned, does not have a neutral pH because it has other ions in it. Okay. So again, here's an acid. It has lots of hydrogen, so it's just our visual look. And a base has lots of hydroxide ions. So that's mainly the things. Acids have hydrogen ions, lots of them. And a base has lots of hydroxide ions, okay? So how do we make a pH of 7? Like, what do we do? So to bring a solution to pH of 7, what happens? What is needed to neutralize pH with a pH of 10? What if we're at a 2? What would we add to get it closer to a 7, right? And so what we would need is either a base to neutralize an acid or an acid to neutralize a base. So what does that mean? Well, remember, we've got hydrogen ions and the hydroxide ions. So if I was over here at 3, which means I have a lot of hydrogen ions, if I add hydroxide ions, they're going to bond to those hydrogen ions, and I'm going to move up, okay? So I'm going to increase my hydroxide ions. So I'm going to move closer to 7. If I'm over here and I have tons of hydroxide ions, I would add hydrogen, and that would increase my hydrogen, which means, and decrease my hydroxide, because some of that hydrogen will bond with them to make water, and it'll move towards 7. So to neutralize an acid, you add a base. To neutralize a base, you add an acid. All right, so let's look at a couple of examples, okay? So I want you to state and think, when I state them, do you think the solution is going to be an acid base, or would it be neutral? So if we add a weak acid and a weak base, so they're about the same distance away from 7, okay? Hopefully you said neutral. This would be a neutral. They would kind of bring each other to the center. A weak acid and a strong base. So now we have a whole lot of hydrogen ions, or no, hydroxide ions and base. I still get them confused. And we have little hydrogen ions. So if we added that, hopefully you would say we would have a base, because a base, we have more hydroxide ions. Number 3, a strong acid and a weak acid. Well, if we add 2 acids together, we're still going to have an acid. How about a strong base and a weak acid? We would have a base still, because the base is stronger. Oops, sorry. How about water, which is neutral? We'll say it's neutral, and a weak acid. We would have still an acid. Water and a weak base. Well, water is neutral. If we add a base, we're still going to get a base. How about a strong acid, a strong base, and water? Water is neutral. We would have a neutral solution. The acid and base would neutralize each other, and water is neutral. So hopefully that helps understanding how you neutralize. Okay, here's another one. As a solution becomes more acidic, what happens to its pH? Does it increase, decrease, stay the same, or does it turn into lemonade? Hopefully you said B. It is B. It does decrease. So acids go lower in the pH, so it does decrease. All right, so those are our notes. Highlight any important notes. Make connections to any of your notes in the left-hand column. Write any questions you may have in the left-hand column, and then use your highlights, connections, and questions for your summary. Write a 3 to 5 sentence summary and turn it in. you have any questions, please let me know.